right, we'll go ahead and get started here. We're excited to have Yongseok Shin from Washington University at St. Louis and also a research fellow at the Federal Reserve Bank of St. Louis talk to us today. We'll be talking about macro models and occupations and industry structure. We'll go until 11:50. Feel free to ask questions as you have them throughout this talk, or if you have questions afterwards, you can catch them after the talk. So,
okay.
Over to you.
Thank you, Christian. So, thank you for coming. I know that some of you are required to be here, but even then, I'm thankful that you are here. Okay. So, I try to give an overview of a set of models that I've been working on. When I set up the slides, I did not know that it was 50 minutes. I thought it was the typical 90 minutes, but luckily for you, it's only 50 minutes. So I will probably talk about the first half, and if I have time, just briefly about the second half of the presentation I prepared. And the structure is a little bit different. The typical macro or economics talk is that people give you some motivation, data, pretty pictures, and then they talk about the model and solution. I will try to reverse that, just kind of have the really heavy-duty stuff out of the way quickly when your attention span is still alive. And then after that, we'll talk about the data and see what happened in the US. Hopefully some of this you are familiar with, others you may not be. Let's see. Okay, so the idea is that, as the title suggests, I want to write on models of macroeconomics models where we think about occupations and sectors. So we see that in the real world, there's manufacturing services, or you can go deeper, there's a food industry, automakers, and other kind of manufacturers, like financial services. And then occupations, well, we have professors, and then clerks, or salesperson, or engineers, or janitors and cooks. Typically, these things are too much of a detail for macroeconomists to kind of think about, but in recent years, people have been really taking interest in this. Of course, labor economists, and you have a lot of labor economists in your department, are much more interested in sectors and occupations, how that affects workers' wages and human capital. So we are kind of trying to bring that aspect into macro model. So the picture is this. It's a bit weird, so let me kind of talk about the production of this economy. So to make things really simple, let's imagine that there are only two sectors in the economy, manufacturing and services. There's a kind of broad classification. Manufacturing, obviously, is an industry that makes things, and then services, the industry that provides service. It's kind of tautological. And then in each sector, the small circles you see are firms. And what do firms do? Well, they produce stuff. And how do they produce stuff? Well, by hiring workers and using their service, labor service. And then what we have is this Z. What is this? So these are managers. So I separate manager as a different occupation because they do interesting things. And then you will see in the data that actually something interesting happening among managers. So there are managers. And what do managers do? They organize workers. And workers have different skills. Some people are very skilled, others are not as skilled. Based on their skill, they sort into different occupations. So let's say that there are three worker occupations. So the typical way we call this is manual. So this kind of very low skills jobs, manual, and routine. So this is kind of what we call typically middle skill jobs. Think about people working in the factory, assembly lines, that's very routine in nature, or some of the service jobs like office secretary, this is very routine in nature. You kind of repeat the things over and over. And then this is cognitive. So these are high-skilled individuals, engineers and architects and professors, or lawyers, doctors. That's how we think about it. So manual, routine, and cognitive. And then these workers work together under the direction of the manager, and then that's the work done in the economy, and using that labor service, manufacturing firms produce manufacturing goods, service firms produce service goods, and then at the end of the day, they get combined one more time to make what's called final goods. This is something you eat. So if, for example, you go to a restaurant and eat, that's obviously, there's a lot of service component to it, but also you have utensils and plates and cups. There's things that are manufactured. Or you go buy a computer, well, you buy the manufactured computer, but also the retail service is embedded when you actually purchase. You don't go to the factory to pick it up. So that's the idea, how manufacturing service kind of get combined to produce what's called final goods. Okay, and you are very welcome to ask questions. I don't know what's the equilibrium in this department, but actually you're really supposed to ask questions. That's what I'm more used to. Okay. So what is this? So there are too many equations, so let me just show you the picture. So what's going on? But the story is simple. So people are just different. How are different? So you have a Z and H plane here. So each dot is a person. So people have two-dimensional skills. What is Z? That's your skill as a manager. What is H? That's your skill as a worker. Okay? So you can imagine some people are very good managers, but they will be kind of lousy workers, and the other way around. Well, if you actually you take the word manager really literally, you look at baseball teams, the managers are typically not MVP players, right? So there are sometimes MVP players become managers later in career, but typically there are some, like I come from St. Louis. I'm not sure whether Mike shared, but manager of St. Louis Cardinals. He was never a major league player. He was always a minor league player all his career, but he won the Manager of the Year award last year. He's like a terrific manager. So the skills are different. Being a boss is different from being a good worker. Okay? And then there are 4 occupations in this economy. Z, you become a manager. H is 0. So you are not a manager, worker, and this is the kind of low skill worker. You do manual jobs. And H1 is the people who choose to be routine workers. And then H2 are the high skilled, high H. These are the people who choose to be cognitive workers, high skilled workers. So there's simple comparative advantage. As I talked about the baseball managers, high Z people, high manager talent people tended to be managers, and high H people, these are people who are really good workers, they tended to be workers. That's pretty simple division. And among workers, how do you actually choose your occupation? So I said something about skill. So let's go back to one of the slides. With education, I don't want you to worry too much about this. Let me just tell you what happens. There are 3 occupations. People are different in terms of their age. So this is a simple example. So what is different about this manual occupation? M0, indexed to 0, as in the H is 0 here. What is different? Something called how much do you produce if you work in this occupation as a worker with your skill H? You look at it, there's no H. It has H bar, but that's not your H. You have your H. So this is occupation where your skill doesn't matter. We just need the bodies. You just show up, and then everybody is really equal. So you can see really low H people, they like this occupation because, well, I have like a near 0 H, but then I will be producing H bar, so I'll be compensated at a higher level than what my skill warrants. And you can see how really smart H people, they don't want to go there because I have a really high H, but in this occupation, manual occupation, I'm not rewarded for my skill. I'm not going to go there. So routine is kind of the normal one. You bring H, that's how much you produce as a worker in that occupation, and that's how much you will be rewarded for. Okay? And then the cognitive occupation is a bit different. What's special? You see H minus chi, and chi is some fixed number. So what is it? The way I like to think about this is you show up to work, and then your boss says, well, we need to solve this problem. And then you have to spend some time just kind of thinking about how you're going to solve that problem. So there's some time you're not really actually actively working, but you're just kind of thinking about how you should approach this project. So there's some fixed cost component to it. Like unlike the routine worker, that doesn't happen. You show up and you're just using your human capital to produce. So you can see, first of all, people whose skill H is lower than chi, they will not even go to that occupation because, well, you will produce 0 or negative numbers, so you're not going to go there, and they will not pay you there, so you don't go there. So that's how you actually separate people based on their worker skill H. It's a one-dimensional worker skill H, how they separate into or sort into these 3 occupations based on their skill. So in equilibrium, the manual, routine, cognitive have low, middle, and high skill people sorting there. So that's the picture. So this is the picture you have. Okay. It's time to use what you learned from intermediate micro. Okay. So I presume most of you heard about the word substitutability and complementarity. Okay? Some goods are substitutes, some goods are complements. Okay? So what's the idea? There's something called elasticity of substitution. This just kind of measure how easy it is to substitute one good with the other. Okay? And then if it's really high, the elasticity is really high, it means that you can freely substitute the two goods. And then if it's very strong complements, if the elasticity is close to zero, then it's very hard to substitute the two. So let me give a simple example. That was kind of in terms of goods that you consume. Typically, that's how we teach in intermediate micro, but also if you can think of a production, let's think of two production functions. One is this. This is how much you produce. This is how many machines, how many units of machines you put in capital, and this is how many workers you put in there. What's the elasticity of substitution between the two? Does anyone know? So if you have one machine and two workers, or two machines and one worker, what happens to the output? It's exactly the same. You don't care, right? So they are very freely substitutable. So in that case, the elasticity of substitution is infinite. So they can be very easily exchanged. And then probably you saw this at some point. Let's see this. This is another production function. Looks weird. You're taking the minimum or the smaller of units of machine and number of workers. This production function actually has a name. It's named after a famous economist. It's called the Leontief production function. And also, he was from Soviet Union, so depending on which way to write the Cyrillic into English, sometimes they use different names, but okay. Anyways, what's special about this? Say if you have one unit of machine and two workers, how much do you produce? Just one. If you have one machine and one worker, how much do you produce? Just one. Because it's a minimum of the two, so even if you have one machine and you add more and more workers, that doesn't do anything. Why? Because the work the machine does and the work that people do are not substitutable whatsoever. So it's a very strong form of complementarity. In this case, that's when the elasticity of substitution between machines and workers are zero, actually. So not substitutable. And this actually will be useful. So there's some debate in the literature. Actually, people don't quite debate this as much. But there's some, if you look at the production function, again, formulas are not important. I'm just kind of pointing out what's happening. So workers in different occupation do their work. And this occupation level output that these workers produce in their occupation, that gets combined as some composite of worker output. And this is where that gets combined. J index jobs, so manual, routine, and cognitive, goes 0, 1, 2. And you're combining them, and the sigma here is the elasticity of substitution across these three jobs. Okay? And then there should be more debate, but some people in the literature say that, oh, this sigma, if you estimate it carefully from the data, it's less than 1, meaning it's less than 1 means it's more complements rather than substitutes. It's not as easy as substitute. It's not 0, but it's a typical number less than 1. And some other parts of the literature, they, instead of kind of estimating, they kind of, well, people should be substitutable. I mean, workers should be more substitutable. So they can assume that sigma is number greater than 1. Maybe this is esoteric, but it is actually important for many of the things that we do. And then I think there should be more debate in the profession, actually. But right now, people are kind of happy to ignore each other. Okay, some people, and which camp am I in? Like, I'm kind of following the complement side. So sigma is number less than 1. So it's closer to Leontief. It's not Leontief. There's some substitutability, but it's close to this, then close to that. Perfect substitutability. Okay, and that is important. Why? So I'm going to do one thing here. Suddenly, the technology changes. And this is sort of, I'll show you the data in a bit. This is sort of what happened in the US data over the last 35 years or so. I'm going to make one change. There's something called the M1. What is it? This M0, M1, and M2. This is the occupation-specific level of technology, right? So if M goes high, what happens? Fixing same capital and worker skills in this routine occupation, suddenly you produce more of output of these routine occupations. So this technology level. So M1 goes up, that's a good thing. Okay? It's actually a good thing for everybody. But so that's what I'm going to do. So people are working happily. And then suddenly I increase the productivity of these occupations. So same machine, same skill, you just produce more. Okay. So what happens to the occupation choice of people? So for this, and I say that this is, I'm going to say that this elasticity of substitution across workers, occupations is sigma is less than 1. So these are complements. That's important because whether it's complements or substitute actually have a different implication. But for intuition, just think about Leontief case. Okay? You have this Leontief production function. So holding other things equal, these guys suddenly become productive, so they produce a lot more than others. What happens to the total production of this farm? So they produce exactly the same as before. These guys suddenly produce more. So that gets combined in a Leontief fashion. They only care about the minimum. What happens to the output of this farm?
I'm not confident about it.
But you shook your head, so that, I think that's just something.
It shouldn't change much?
Exactly. The answer is that it does not change if it's Leontief. It's a minimum. If there are 4 arguments, and then 3 of them remain the same, only 1 increases dramatically, the output doesn't change because it's only about the minimum. The minimum didn't change. Okay. So then what do? The firm, if the manager knows anything about production, what should the firm do? What you want to do is, these guys became more productive, but it's wasted because the other guys are not producing. They are not keeping up with it. So what do? You want to send more people to other occupations. You want to have more managers. You want to have more workers in the manual and the routine. And then cognitive. So you're going to have a shrinking employment of this routine job workers, in the middle skill workers. They will move to either low skill, high skill, or managers. So that's the comparative static. If you understand this, and the paper is kind of done. Okay? This is the picture. Okay? I should make a movie, but just to, I'm dramatizing obviously, but how you see H1 shrinks, all other 3 occupations gonna become larger. Okay? And you're gonna see in the data, that's basically what was happening in the US economy. These routine jobs, so-called routine and mid-skill jobs, have been disappearing. Okay. And why? Did something bad happen to these jobs? No, actually something good happened. Actually, these guys became really productive. Okay. So you think, wait a minute, that's kind of weird. I mean, it's a productive, why is that occupation shrinking when it's so productive? Well, because the Leontief intuition. These guys became so productive, so to keep up with their productivity gains, you have to send production workers and capital to other occupations. And that's how we typically think of, economists typically explain why agriculture shrank, the sector, agricultural sector. How many farmers do you know? Not that many. Oh, you know.
I grew up on a farm.
Okay, good. So they exist. So existence is proven. So they exist. They're about 3% of the employment in the United States, agriculture workers. Go back 100 years. What fraction of the US population of agriculture workers? It's go to 70%. Okay, pretty much everybody's farmers. And then what happened to the farmers? Did something bad happen to farms? No, actually, the farmers became so productive. You get all the, first you use animals, but then you get all these internal combustion engines. You have tractors and combine harvesters and everything. And then also the biotech came in and they kind of produced crops that are more resistant to disease and things like that. So it became so productive that, well, we don't really need that many farmers to feed like the nation. So people have been moving to other sectors. Exactly the same thing. Productivity is so high that people are moving away. Okay? So that's occupation space. And what about sectors? Okay, we just talked about sectors. So that's something very similar will happen here. Okay. So I said it's a macro model of occupation and sectors. So what do we do about sectors? So far, there was no mention of sectors whatsoever. Manufacturing and service, so I'm going to talk about two sectors in the economy. There's something interesting, some difference between the two sectors, employment-wise. So this is basically, you can think of this as, there are 11 occupations, starting from manager to low-skilled service workers. I'm sorting them by their average wage in 1980. So average wage, you think of it as a proxy of a skill. So managers are very high skilled. Low-skilled service and administrative support people are lower skilled. And then in the middle skill will be machine operators, transportation workers, sales and technicians, and mechanics, and miners and print workers. Okay? So these are routine workers. And the professional managerial support and managers are the cognitive workers. So what is these bars? The bars for each occupation that's sorted by their average wage in 1980 or measure of skill. What fraction of that people actually work in a manufacturing sector rather than service sector? So you see that, and this is 1980. So at this point, manufacturing accounts for only like say 30%, about 30% of the employment in the US. But you look at machine operators, about 90% of them work in the manufacturing sector. Okay? And then these numbers are very high in the middle, and then low in the low skill and high skill. So from this, what we conclude is that, actually, manufacturing is a very routine or middle skill intensive sector. Okay? So I have two sectors, manufacturing and services. What are the differences? Again, I'm just pointing to you. You don't have to understand this. I'm just pointing to you where it is buried in the model. There's something called new. This is basically how many of industry I uses how many of occupation J. And then manufacturing uses a lot of routine workers. So new of M1, that's intensity of routine workers in manufacturing, is much higher than new of S1, that's intensity of routine workers in services. So manufacturing uses these routine workers more. And another interesting thing, although that's not doesn't have to be the case here, but another interesting thing is that there's something called the ADA, another blue at the top. That's basically how managers and workers, their work get combined. So ADA is importance of managers in production. So what we find is that in manufacturing, at least in 1980, managers were not as important as services. But now, in manufacturing, you will see the picture in a bit. Managers are as important as in services. Okay? Anyways, but for now, the only thing I need to tell you is that manufacturing uses all these routine middle skill workers a lot more than service does, actually. Okay. So this is kind of the previous picture. I just show it because it took me a long time to actually make this picture. So you can imagine people H and Z distributed in uniform fashion, as I'm assuming uniform distribution. And then people are first divided into occupations, the map that you saw before. And then now also within occupation, they are divided into sectors. Red for services, blue for manufacturing. That's the conclusion. Okay, but let's do this again. I mean, we're repeating what we just did, and then we'll change one more thing. So what's going on? So this is same. This is how occupation choice is made, and then people are split into manufacturing and services. Okay. And then same thing. Now what I'm going to do is I will not let people move between sectors. Okay? If you're in manufacturing, you have to be in manufacturing. If you're in service, you have to be in services. But I'm going to make the same change. Remember M1, that's how productive this routine technology is. So I'm going to increase M1 just like before. And you know what to expect. Oh, because these are complements, what's going to happen is that this occupation is so productive that it shrinks and other occupations actually expand. That's what you expect. Exactly what happened. Okay? And then the height of these two bars do not change because I'm not allowing people to move across sectors. Okay. So, but that's not an equilibrium. Why? One thing I didn't tell you, but here, is that you have two sectors in the economy, manufacturing and services, and you see this one Greek letter, epsilon there. So what's happening here? So this is basically how manufacturing output and service output get combined to produce our final output. Okay? The retail service and computer get combined to produce our consumption of computers. Right? So how substitutable are they? And then you go to the literature. This one I didn't estimate. You go to the literature, and then people find actually this epsilon to be a number very close to, much less than 1, very close to 0 actually. So they're arguing that, man, at this level of manufacturing service distinction, the elasticity of substitution between the two sectors outputs are close to Leontief, really. But of course, that's partly, that's important for my research, but that's partly because we only think of manufacturing services. If you actually have, there are 20 manufacturing sectors and there are 10 service sectors, there are 30 of them, then if you estimate the elasticity of substitution, it's actually close to 1. Okay? So the fact that manufacturing service is very close to, substitutability is close to 0, that is an artifact of the fact that we are looking at 2 big sectors. But if you actually look at fine classification, many sectors, and the sectors are kind of more substitutable to one another. Yeah. Anyways, but that's not for today. So let's use that intuition. So we all agree that, these guys became more productive, these guys actually have to shrink. Fine. It's a question. At this point, I didn't let people move into manufacturing service. Which sector do you think increased its production by more? Because both sectors increase their production. Why? Because some workers are getting more productive. Okay? Is it manufacturing that increases their production more, or is it service that increases their production more? The hint is that manufacturing uses these guys a lot more intensively, and those are the guys who actually just saw the technology increase. Okay? So what I'm saying is, this M1, that's the technology that makes these routine workers more productive, regardless of their skill, that benefits both sectors. But one sector uses that type of technology and that kind of workers a lot more than the other. So, holding other things equal, what do you think happens to the output of manufacturing services? Which one increases by more, manufacturing or services? Manufacturing, can you give me a reason? First of all, it is correct, yes.
What you just explained, basically, if you are more productive in the area that you're using workers the most, then
you're exposed more, exactly. Yeah, your intuition is exactly correct. So you're exposed more to that technology improvement, so you will actually increase your output more than service does. Okay, this is the final layer. We just talked about how manufacturing and service outputs are almost like a Leontief. They are not substitutable. This is not an equilibrium. Something has to happen. Manufacturing is now producing more than services, but production function Leontief, so some of the increased manufacturing output is being wasted. What should we do? What should the economy do to make sure that we don't waste anything? You have a Leontief production function, manufacturing output goes up, service doesn't go as much, but Leontief is a function of the minimum. So some of the increased output in manufacturing is completely wasted because that doesn't produce the real output Y in the end. What should we do?
Would we have people leave manufacturing to go to services?
Absolutely, exactly. So same thing. That's how people within a sector, people left to routine jobs to go to other occupations. So now, because manufacturing is much more productive, because it's more exposed to this routine technology, now people move from manufacturing to services. So the bar changes like this. Yeah? So we talked about 3 things, and then only one thing changed in the economy. So of course, a lot of things changed in the economy, but in this example, only one thing changed. What changed? The routine workers became more productive. I'm not saying that routine workers became smarter. Their age is still the same. It's just the technology changed in a way that they make these people more productive. Okay? You can think of automation in the assembly line. So there used to be 10 workers tightening bolts and nuts, but then now robots do it, so that you only need 2 workers to produce the exact same output. Or before, secretaries had to make a lot of phone calls and work with the Rolodexes. Probably you don't even know what Rolodex is. But then now everything is done in computer and email and scheduling software. So one secretary can handle more work, routine work. Okay? So that's sort of what is happening in the workplace. That's one thing. The only thing that just changed in these examples, and it has at least 3 impacts, depending on how you count. But one impact is, well, among the workers, the routine workers actually shrink, and now you have more employment in the low-skill, manual, and high-skill cognitive. Okay. This is typically known as polarization. Okay. So polarization, probably to you, means political polarization. That's what everybody talks about. But for many economists, polarization means actually this shape, that middle-skill jobs are shrinking. Now the jobs you have is the high-skill jobs or low-skill jobs. And second thing is the rise of managers. This is exactly the same mechanism, that when this routine jobs shrink, workers become more productive. So to keep up with that, actually, you have to hire more managers. Okay? Sorry, from here to here, manager expands, there are more managers. The third is a structure, what we call structural change. Because manufacturing services complements and manufacturing is more dependent on these routine workers, people move from manufacturing to service sectors. Okay? These are 3 things that happen with just one thing. Technology change that made these routine workers more productive. Okay, so the heavy-duty stuff is done. Let's look at the pictures. Okay. So what is this? This is so-called polarization. I wish I had come up with this, but it's much more famous people. David Autor and David Dorn came up with this word polarization. And the dotted line is their picture. I mean, I extended it because they looked at up to 2005, so I extended to 2013. So what is this? We are sorting occupations according to the 1980 average wage of that occupation. So the highest average wage occupation in 1980, any guess? Aeronautical engineers. So if you care about that, you are in the wrong major. And then 0 is actually janitors. Okay, so janitors is an occupation of the about 340 occupations that we classify. They have the lowest average wage, and then aeronautical engineers have the highest average wage. But obviously, other things kind of fall in between. Like you have doctors, lawyers there, and but if you want to know where the CEOs fall, typically this is based on census. And typically, I don't think the CEOs necessarily report their salary, and also there's a top coding. So Steve Jobs say something about his salary, it's not here. So that's why I think a CEO should be here, but it's not there. Okay. Anyways, so you kind of sort occupation by their average wage in 1980, high skill and low skill, that's the idea. And then you look at what happens to employment share of that occupation. How many people are working in that occupation? You see the dotted line between 1980 and 2013. So what does it mean? Well, there's 0 here. What it shows is that the low wage or low skill occupations see increase in the number of people working in their occupation. Same happens here. It happens on the right-hand side. Actually, the really high-paying occupations, cognitive occupations, the number of people working there actually increasing. Then where is the negative number? Well, these are routine middle-skill jobs. These are, as you can imagine, the administrators, machine operators, and transportation workers, the mechanics and minor and precision workers. Actually, the numbers are falling. So this is sort of what politicians say. This is what politicians kind of point to when they're talking about the collapse of the middle class in the US. You kind of middle class jobs are kind of shrinking, and then low skill and high skill jobs are rising. So this is the polarization. Then the bars are it's a 330 occupations. It's too many to keep track of. So what we did is that we just look at 11 occupations, and then we look at what happens to the occupation share. And then we saw low skill service, and the 3 cognitive occupations, professional, manager, support manager, they increase. With the exception of sales and technicians, all the other jobs kind of fall. Actually, one reason this technician job increase, our classification of technician includes health workers, like nurses, for example. So that's a big part of this increase in technicians between 1980 and 2010. So that's the polarization. And then, so people typically hear about polarization say, oh, it's because, say, China. Because, for the record, I'm not from China, so it's not like I'm trying to defend China, anything. Okay, I'm neutral observer here. So people say, oh, because China joined the WTO and then they start like stealing all the US manufacturing jobs. That's a very common commentary. That has a little bit of a problem. And it's actually, if you take away one thing from this lecture, this is it. This is our addition to this debate. What is this? I'm actually now plotting the same thing, sorting occupation by skill, high average wage in 1980, and say what happens to the number of people working in their occupation between 1980 and 2013, 2015 actually. But I'm doing it for manufacturing and services separately. Okay? So blue bars are manufacturing, red bars are services. So within manufacturing. So let's go with manufacturing. First of all, what do you notice about manufacturing? Pretty much all numbers are negative. It's not surprising because, well, I just told you, I guess I didn't tell you. Okay, so manufacturing has been losing employment over this time period. So that's why pretty much in all occupations, the number of people working in their occupation in manufacturing sector is actually falling. That's not surprising. Where is it concentrated? The middle skill, the routine jobs. Okay, machine operators to miners. Okay, there's big bars here. And actually, you see some increase in managers, even in manufacturing sector. So manufacturing is overall is kind of falling in employment, but managers actually doing well. But then you look at services. Now, what you notice, the most numbers are positive. Why? Again, the opposite side of the coin, that service as a whole has been employing more and more people over time. So that's bars are high. But you look at the shape, and it's identical. The level is different, but the shape is the same, meaning in services, the red bars, within services, what happened? The low skill gained employment, the high skill gained employment, and the middle skill jobs in services actually lost employment when the sector as a whole was actually rising. So if it's really about trade, manufacturing gets traded all the time. Trade in service is much harder. It's harder to trade your haircut or restaurant operation. Actually now people do. You can branch out and there's all kinds of other things. Or now the information technology allows you to actually export your accounting services, for example. You can have clients in other countries, things like that. But still, if you compare the trade, especially in early on, in 80s and 90s, there's very little trade in services. There's a lot of trade in manufacturing. So this picture, I think, says that, yeah, trade cannot be the number one culprit because service, which is kind of more immune to trade, they saw the exactly same thing. The middle skill jobs kind of collapse, relatively speaking, and then high and low end jobs kind of go up. So this is it. So this picture kind of says that, yeah, maybe it's not trade. It's more like a technology that affects both manufacturing and services almost equally. The other thing interesting about managers. So managers is a very interesting occupation. So first of all, the dashed line is what fraction of people are working are classified as managers. Actually, it's not a very simple thing because you have to work with the data very rigorously to kind of arrive at a very consistent definition of who's a manager. But anyways, let's say that we agree on that. It includes CEOs, but also includes middle-level managers, like human resource managers and purchasing managers and all these things. What you see is that they used to be about 11% of the working population, or like the employed population, and now you actually have more managers than before, about 13.5. Actually, the peak was in 2005. It was about 14.5, so you had a lot more managers. But then that kind of collapsed after the Great Recession a little bit. Okay, but still, it's high. So there are more managers than before. Not only that, some people say, is it because we are calling everybody a manager? That is not true. If that is indeed true, if you're calling everybody manager, the average wage of manager shouldn't rise because you are calling someone who's actually not a manager, not making that much money. Now you're classified as a manager, then you expect if you compute the average salary of manager, that will be brought down by the people who shouldn't be actually classified as managers. But that's not the case. What you see, the solid line is that what is this number? It's basically managerial premium, meaning what is 1.45 in 1980? You look at all the managers and compute the average wage. That's about 45% higher than all other workers' average wage. Okay? So you don't know anything about this person, but you know that this person is a manager. Should earn about 45% more than other workers. That number is now 90%. Okay? So managers are earning a lot more than before. Incidentally, this actually is very similar to a pattern in college premium. And it's good news for you. You have to finish it actually. So college dropouts do not get a big premium, but if you actually compute in 1980, what's the average wage of a college graduate, meaning someone with a 4-year degree, divided by average wage of a high school graduate who never went to college? That was about 45%. And that number is now about 90% in 2010. So the college premium, the average college graduate's wage is almost double the wage of an average high school graduate. So you may think that, the number is kind of similar. So is it the same thing? Yes, good.
I actually have, going back a little bit,
yes.
How would you explain the drop in managers after their session?
So, good question. We didn't really look at it. so we are kind of just happy with what it has written. At some point, I should look at it. Yes, but it's a good question. Actually, yeah, it's a good question in the sense that I'm not showing you, but it was peak was in 2005, so the fall was actually even more dramatic. So we could look at the data and see sort of what's happening. And it's not like business is failing, because we did the measure for people who are like proprietors, and sometimes we count them as managers and sometimes we don't, and the pattern is the same. So it's not like, after Great Recession, you have all these businesses kind of failed, so that's why those people are not managers anymore. That's not the answer, actually. Okay. So one interesting thing about manager is that you think these people are mostly college graduates, but surprisingly no. So the story that, manager premium and college premium, not only the magnitude is the same, but it's driven by the same people, that's not true, it turns out. Manager is a very interesting occupation. You have people with very little education, like, I don't know, there was some joke about this in the tech community, I think Glenn Ellison was a high school graduate, and Mark Zuckerberg and Bill Gates were college dropouts. They didn't get their degrees. It didn't matter. But so just an example, if you look at managers, this is not always very highly educated people. Another reason why I want to separate this manager skill Z and worker skill H. Okay. And then this is manager employment by sector. So what am I saying? It's a red line first. You look at all the service workers and look at among the service workers, what fraction of them are managers? That's the red line. So about 13%. It's kind of flat. The service have more managers. It's not very surprising because you look at all the establishments, like for example, you go to In-N-Out Burger, they have a manager. They have some employees, but they have managers. You go to a manufacturing plant, they have one manager, but then also they have a problem overseeing a lot bigger group of workers, actually. So service tends to be more smaller establishment, so that's why they have more managers. And look at what happens to managers in manufacturing. In 1980, less than 8% of people working in manufacturing were classified as managers. Now in 2010, about 13%. So you see a big increase in managers. So what was happening in manufacturing? You actually look at the micro data. What's happening is the manufacturing is losing employment, but mostly they lose the assembly workers, basically, the line workers. They are being replaced through automation and by robots, but managers actually there. And with the importance of, like, say, supply chain and logistics and everything, now actually they hire more and more managers. Okay? And this I come back to, because this is going to be another important point when I conclude. Okay, so two things. This picture is the rise of managers in the US, which we find very interesting. And the other thing I'm not showing here is that for each occupation, so you look at the people in the same occupation, you look at the wage inequality among them. So this is more like, relative to workers, managers are making more. Okay, this was it, right? So this is between occupation comparison of wage. But you can also look at within occupation comparison, meaning look at all the managers. And let's compute the wage inequality among the managers. Guess what? So managers, first of all, has the largest within manager wage within occupation wage inequality to begin with. And then between 1980 and 2010, the within occupation wage inequality increased the most among managers, not any other occupations. Okay? So what's quite interesting is that a lot of this inequality that we're talking about is happening among, like, people who are working for high skill, like cognitive occupations, especially managers. And this doesn't, as I said, this doesn't really include, this is survey data and it's top coding, so it doesn't really include the Fortune 500 CEOs who are making about 1,300 times more than the median workers. Okay, so we're not including that, but even then, it's like really average is increasing, but also the inequality among them is increasing very fast. Okay. And this is something we just mentioned. This is the structural change part, how people are moving from manufacturing to services. 1980, you look at it, about 60% of US workers in services, and then about 35% in manufacturing. Agriculture is negligible all periods, but then now actually that number, blue, has increased. So you can see that actually services increased by more. Okay. So this is the data. So in the remaining 4 minutes, let me actually show you 2 pictures and conclude. Or 3 pictures actually, 2 pictures and then conclude. Okay. So one is something we found interesting because, as I said, I guess I didn't talk about this in explicitly. People typically have this idea that, well, manufacturing is shrinking, so it's kind of like why we kind of say that agriculture shrank. Agriculture shrank because it has become so much more productive than other sectors, so we don't need as many farmers. So that's the typical explanation given from shrinking of manufacturing sector, the shrinking red here, or orange. And then what's kind of interesting is that, well, it's got to be part of the story. Why? Well, from 1970s, and I actually go to 1960s, manufacturing has been shrinking all the time. Okay? But then if this is blue is a productivity of manufacturing and red is productivity of services, between 1950 and 1980, well, they grew by about the same. You cannot say that between 1950 and 1980, manufacturing productivity rises by so much. You cannot say that. But after 1980, yes, you can say that. There's a huge gap. So one thing that's interesting is that, yeah, the structural change is actually a very constant phenomenon, but then the productivity is not like that, so maybe you want to have something else. The second thing is, what explains, okay, why some occupations became more productive and others didn't? Okay, so that's the question. So people thought, well, maybe it's college. Maybe because there's a big literature on explaining why college premium has increased. So they said that, well, there's a technological change that's favoring college graduates. It's not as good a picture because this is showing by how much the productivity of the occupation has increased. So high means fast growing productivity of occupation. And then you are kind of comparing that with fraction of people who has college degrees in that occupation, or the increase in the fraction of people with college degrees in that occupation. And then these numbers actually, well, not very correlated, and it's actually negative. So it's a little bit, the sign is not even right. So this story that, oh, you have people with a lot of college degrees, that's why your occupation level productivity increased. No, it says it's negative. So actually, occupation with a lot of college people, they saw their productivity falling, relatively speaking. So that's not it. And then the picture, I guess, I don't know why I don't have that picture. Oh, here, this is, no, I have it. Okay, so what is this? So the one explains why some occupation became more productive than others. For each occupation, we can look at what do people do in this occupation. And then you can say, oh, you're doing these things as a worker in this occupation. Some of these things are classified as routine, repetitive work, and some other things are non-routine. And what's really interesting is the dashed line almost perfectly correlates, but not almost, but very well correlates with the occupation level productivity growth. That's how routine in nature your job is. Like machine operators, very routine in nature, as you can imagine. They saw a huge increase in occupation level productivity. And then managers, not very routine in nature. You see a low bar here. And then they actually saw decrease in occupation level productivity. So one hint is that things that are routine, that's so occupation level productivity increase a lot. So we think it's more automation or using machines to replace workers. But the other interesting one, but goes the same, is actually red line. That's basically how much interpersonal interaction you need in your occupation. Okay? What you see is that it's actually the negative of that. So what you see is that machine operators, it's very routine in nature, and the high red means that very little interpersonal interaction. And those are the things that actually saw a lot of increase in occupational productivity. Managers, not very routine, and also very low red means that it requires a lot of interpersonal interactions. The productivity of that occupation didn't go down. So again, it supports the automation story that if your job requires a lot of interpersonal interaction, probably it's very hard to automate. Let me finish with just one thing. People say that, look, manufacturing is shrinking, that's why middle class is losing their jobs, so we should support the manufacturing sector. We hear that all the time. You have to be careful. Manufacturing, because it's more dependent on routine jobs, it has polarized very fast. So think about this. Now, let's say you subsidize manufacturing jobs and bring like 100 manufacturing jobs back. How many middle-skill jobs do you think you will bring back? Turns out only 25. Why? Because manufacturing in 1980 used a lot of these routine jobs, but then now today's manufacturing workplace looks very different from the 1980 manufacturing workplace. It's all robots. So you bring 100 manufacturing jobs, you are bringing in engineers and some delivery people, not the middle class jobs. Okay? So this idea about what happened within sector is very important when you're thinking about the policy response. Okay? Thank you.